Welcome back, everybody. Today we're taking a deep dive into a mission that, well, it sounds like something straight out of science fiction.
Oh, yeah.
Deflecting asteroids.
Wow.
The European Space Agency's Hera spacecraft is going to give us a front row seat to see what happens after humanity's first attempt at moving a celestial body.
Really incredible.
It is. The
Yeah.
target is a binary asteroid system called Didymos, millions of miles away.
Mm-hmm.
See, NASA already made history when they slammed their DART spacecraft right into the smaller asteroid Dimorphos.
Right.
Hera is following DART to gather data, essentially becoming our cosmic detective at the scene of this groundbreaking planetary defense experiment.
A cosmic detective. I like that.
Yeah, it's a great way to think about it.
Yeah.
Hera just pulled off this amazing maneuver using Mars's gravity to speed up its trip.
Yeah.
It's rarely done in space exploration.
And pretty cool.
It is really cool.
Yeah.
What will Hera discover when it reaches Didymos? What does this all mean for protecting our planet?
Well, that's what we're here to find out.
Let's find out. So, what's so fascinating about this mission?
Well, every step has to be so carefully orchestrated.
Yeah.
Hera needed a serious speed boost if it was going to reach Didymos, in a reasonable time frame.
Right.
That's where this Mars gravity assist comes in.
It's like a slingshot, right? A
Yeah.
cosmic slingshot.
Exactly.
I read that Hera had to perform 2 thruster burns,
Yes.
the first in October and then another in November,
Mm-hmm.
just to align itself perfectly for this maneuver.
Precisely. By harnessing Mars's gravity, Hera basically stole some of the planet's momentum, giving it a significant speed boost and shaving months off its travel time to Didymos.
Wow.
Yeah, it's amazing.
I bet that saved a ton of fuel, too.
Oh, yeah, of course.
Speaking of this Mars flyby, I heard that Hera is going to get a close look at one of Mars' moons, Deimos.
That's right, that's an added bonus.
Yeah.
Hera will be flying by Deimos at a distance of just 300 kilometers, which is a rare opportunity to study this relatively unknown moon up close.
Wow.
We'll be able to analyze its composition, map its surface features, and we might even be able to get some insights into its internal structure.
And I understand that this Deimos data will complement observations from other missions that are already studying Mars.
Absolutely.
It's fantastic.
Missions like the UAE's HOPE orbiter and the upcoming JXA DLR MMX mission are also gathering data on Mars and its moons.
Yeah.
Combining all of these data sets will give us a much richer understanding of the Martian system.
It's amazing. A great example of scientific collaboration.
Oh, yeah, the best kind.
Okay, so Hera gets this speed boost from Mars and then a close encounter with Deimos.
Right.
But let's talk about the main event. Hera arriving at Didymos in late 2026.
Okay.
It's going to investigate what happened when DART collided with Dimorphos,
Yeah,
which is, it's crucial for figuring out how to deflect potentially hazardous asteroids.
exactly. Hera will arrive after one last deep space maneuver in February 2026, and then a series of rendezvous maneuvers to fine-tune its approach to Didymos.
Oh.
Once it's there, it'll start its investigation equipped with a whole suite of sophisticated instruments.
What will Hera actually be looking for at Didymos?
Well, Hera will be analyzing the crater that was created by that DART impact, looking at its shape, size, and the material that got ejected.
Uh-huh.
This is going to give us crucial information about Dimorphos' internal structure and how it reacted to the impact.
Okay.
Hera will also be studying Dimorphos' orbit around Didymos, measuring any changes caused by that DART impact.
Okay.
This data will be essential for validating and refining our models of asteroid deflection.
It sounds like piecing together this really complex puzzle.
It is.
I'm guessing Hera's going to use a variety of instruments to collect all this data.
Absolutely.
Yeah.
It has cameras for detailed imagery, spectrometers to analyze the composition of the asteroid's surface, and a laser altimeter to create a precise 3D map of the terrain.
Wow.
Hera even carries 2 CubeSats.
CubeSats.
Yeah, they're tiny, incredibly capable satellites that will be deployed to get even closer to Dimorphos and gather additional data.
Wow, CubeSats.
Yeah.
They sound amazing. What will those be focusing on?
One of the CubeSats will measure Dimorphos' gravity field, which will give us insights into its internal structure and mass distribution.
Okay.
And the other one will use radar to probe beneath the surface, giving us a glimpse into the asteroid's subsurface composition.
Wow.
Yeah.
All of this data beamed back to Earth will provide scientists with an unprecedented view of the aftermath of the DART impact.
It really will.
It's so exciting to think that we're on the cusp of learning so much about asteroids and how to potentially deflect them.
It's truly groundbreaking.
Yeah.
Understanding these binary asteroid systems like Didymos is critical, especially since they're surprisingly common in our solar system.
Oh, really?
If we ever need to deflect an asteroid to protect Earth, This knowledge will be invaluable.
So Hera's mission ties directly into planetary defense, which is a topic I know we're both deeply interested in.
Oh yeah, definitely.
The idea of an asteroid impact might sound like something out of a movie, but the threat is real.
It is. And while Hera is a significant step forward in our understanding of asteroid deflection, there's still so much more to learn.
Which makes me wonder, are we doing enough to prepare for this threat? You know, the Chelyabinsk meteor in 2013 was a stark reminder that even relatively small asteroids can cause significant damage.
You're right. That was a major wake-up call.
Yeah.
That Chelyabinsk meteor was only about 20 meters across, but it exploded over Russia with the force of hundreds of kilotons of TNT.
Wow.
Thousands of people were injured by the shock wave, and the damage was extensive.
Yeah.
Now imagine something larger striking a populated area.
Oh, wow.
It's a sobering thought.
It really is, but it also highlights the importance of missions like Hera and these broader efforts to understand and mitigate the asteroid threat.
Absolutely.
It feels like we're at a turning point, moving from passive observation to active engagement with these celestial objects.
Absolutely.
Yeah.
Hera is just one piece of a much larger puzzle. Agencies like ESA are actively tracking near-Earth objects, developing deflection technologies, and planning future missions to further refine our planetary defense strategies.
That's reassuring to hear.
Yeah.
It feels like we're entering a new era of space exploration, one where protecting our planet is a top priority.
It really does feel that way.
But where do we go from here? What are the next steps in this, cosmic balancing act of understanding and mitigating the risks posed by asteroids? We'll dive deeper into that right after this.
Sounds good. Well, it's a multifaceted challenge, that's for sure.
Yeah.
We need to keep refining our ability to detect and track potential threats, which means investing in more advanced telescopes and early warning systems.
It seems like that's already happening, right?
It is.
I know there are ongoing surveys to identify and catalog near-Earth objects.
Yes, but there's always room for improvement.
Right.
We need to be able to detect smaller objects and track their orbits more precisely.
Yeah.
And anticipate potential close encounters with Earth well in advance.
That makes sense. The earlier we know about a potential threat, the more time we have to develop and deploy a deflection strategy.
Exactly.
But what about the deflection technology itself?
Yeah.
Are there other approaches besides the kinetic impactor method that DART used?
There are. Scientists are exploring a variety of possibilities, each with its own advantages and challenges.
Okay.
One concept involves using a spacecraft's gravity to gently nudge an asteroid off course over an extended period.
Interesting.
It's like a cosmic tugboat,
Uh-huh.
subtly altering the asteroid's trajectory.
That sounds pretty ingenious, but wouldn't that take a long time to work?
It would,
Yeah.
which is why it's best suited for asteroids we detect far in advance.
Okay.
Another approach involves using focused solar energy to vaporize a small portion of the asteroid's surface.
Okay.
This creates a jet of material that acts like a thruster, pushing the asteroid in the opposite direction.
So instead of slamming into the asteroid, we're using the sun's energy to gently nudge it away.
That's the idea.
It almost sounds too elegant to be true.
Real. Well, it's still very much in the conceptual stage,
Okay.
but it holds promise.
Yeah.
There are also some ideas involving nuclear explosives,
Oh, wow.
but those are generally considered a last resort because of the potential risks and complexities.
Right.
Yeah.
It's fascinating to think about the different tools and techniques we might use in the future to protect our planet.
Yeah, it really is.
But as you mentioned earlier, planetary defense goes beyond just deflection technologies.
It does.
Public awareness and international collaboration are also critical factors.
Absolutely. The more people understand about the asteroid threat, the more likely we are to garner support for the research, development, and implementation of effective planetary defense strategies.
It's like anything else, knowledge is power.
Right.
The more we know about the risks, the better equipped we are to address them.
Exactly.
And international collaboration is key, right?
It is.
This isn't something that any one nation can tackle alone.
Precisely. Asteroid impacts are a global threat, and addressing them requires a global response. Sharing data, expertise, and resources is essential for developing a comprehensive and effective planetary defense system.
That makes perfect sense.
Yeah.
It's like a cosmic neighborhood watch
I like that.
with everyone looking out for each other.
Yeah.
So, in the big picture, where do missions like Hera fit into all of this?
Well, Hera is playing a crucial role in advancing our understanding of asteroid deflection techniques.
Okay.
The data it collects will help us validate and refine our models, which allows us to design more effective missions in the future.
So it's like a crucial stepping stone, paving the way for even more ambitious planetary defense efforts.
That's a great way to put it.
And it's not just about protecting Earth from catastrophic impacts, right?
Right.
Even smaller asteroids can pose a significant threat.
They can.
We talked about the Chelyabinsk meteor earlier,
Mm-hmm.
but there have been other notable events in recent history.
There have.
Yeah.
You're right. In 2019, an asteroid estimated to be about 100 meters in diameter passed within 70,000 kilometers of Earth.
Wow.
That's less than 1/5 the distance to the moon.
Oh, wow.
And we only detected it a few days before its closest approach.
That's a bit too close for comfort. It really highlights the importance of continuous monitoring and early detection.
It really does.
It makes me think about something you said earlier about the potential for utilizing asteroid resources.
Uh-huh.
Could there be a connection between planetary defense and resource utilization?
That's a very interesting question. And the answer is potentially yes.
Okay.
As we develop technologies for deflecting asteroids, those same technologies could be adapted for capturing and redirecting them to safe orbits,
Okay.
where we could potentially mine their valuable resources.
So we could turn a potential threat into a valuable asset.
Exactly.
That's a fascinating thought.
It is.
It seems like the future of space exploration holds incredible possibilities, both in terms of protecting our planet and expanding our understanding of the cosmos.
It does. And as we delve deeper into these realms, who knows what other incredible discoveries and advancements await us. But let's not get ahead of ourselves.
Okay.
We've covered a lot of ground in this deep dive, from the intricate details of Hera's mission to the broader implications of planetary defense.
It's been an enlightening journey so far.
Yeah.
And as we wrap up this discussion, I'm curious to hear your final thoughts on what all of this means for humanity.
Okay.
What are the key takeaways you hope our listener will ponder as they continue to follow Hera's progress and the ongoing efforts to safeguard our planet?
I think it does feel like we're at a pivotal moment.
We're not just exploring space for the sake of exploration anymore.
Right.
We're taking concrete steps to protect ourselves and ensure the survival of our species.
It is a humbling realization, recognizing that our planet, our home, is just this one small, vulnerable world in this vast and chaotic universe.
And it's not just about surviving, it's about thriving.
Yeah.
We talked about the potential for asteroid mining,
Right.
turning a potential threat into valuable resources.
Uh-huh.
Imagine the possibilities.
It's exciting to consider.
Yeah.
Resources from asteroids could revolutionize space exploration, making it more sustainable and accessible.
Yeah.
It could even help solve problems here on Earth, providing us with access to rare minerals and metals.
It's incredible to think about how far we've come.
It is.
From gazing at the stars to launching probes and telescopes
Yeah.
to actually landing on the moon. And now we're taking steps to defend our planet from these cosmic threats.
It's a testament to human ingenuity, to our never-ending desire to understand and explore the universe around us.
It is.
But with this increased capability comes increased responsibility.
That's a really crucial point.
Yeah.
We have a responsibility to approach space exploration ethically and sustainably,
Yes.
considering the consequences of our actions.
Absolutely.
And it's not just about what governments and space agencies are doing.
No.
It's about each of us playing a role, staying informed and engaged.
Absolutely. The more we understand about space, the more we appreciate its wonders and its challenges.
Yeah.
It's about fostering this sense of global citizenship, recognizing that we're all interconnected, sharing this fragile planet in this vast expanse of the cosmos.
So as Hera continues its journey towards Didymos, let's keep in mind the bigger picture here.
Yeah.
It's about pushing the boundaries of knowledge,
Hmm.
protecting our planet, and ultimately securing a future for humanity among the stars.
Well said.
Yeah.
And let's not forget the importance of curiosity and wonder.
Yeah.
It's what drives us to explore, to innovate, to reach for the impossible.
This deep dive has certainly sparked my curiosity.
Fun too.
It's really left me with this sense of awe at the scale and the complexity of the universe, but also this renewed sense of hope and determination.
Yeah.
We have the capacity to face these challenges and to create a brighter future for ourselves and for generations to come.
Absolutely.
Thanks for taking us on this deep dive.
It's been my pleasure.
I think it's safe to say that we've all learned a lot about Hera and planetary defense and the incredible potential ahead of us as we continue to explore our place in the cosmos.
And to our listeners, keep looking up, keep asking questions, and never lose sight of the wonder that surrounds us.
That's a great note to end on. Thanks again for joining us for this deep dive. We'll see you next time.